Hello, algebra class. I hope that everybody is doing well. We are beginning in another section. We're still in chapter 7, but we're in section 7-5, day 1. And we're talking about something called rational exponents and radicals. What I'd like for you to be able to do by the end of this class or this lesson is to define what a radical is and rewrite radical expressions with into exponential form. So far, you've only seen 3 main types of exponents. For example, 4 to the 0 is 1, so you've seen 0 exponents. Or 4 squared is 16. You've seen exponents where it's a whole number. Or you've seen like 4 to the negative 2, which would be 1 over 16. So you've seen 0, positive numbers, and negative numbers. You have not seen fractions. So that's what we're going to talk about today. But let's cover a little bit of vocabulary first. We can see in our image here, we have this little guide. This is called a radical sign. And if you have a number, this kind of looks like an arm to me, and I call this the elbow. So if this number inside of the elbow of the radical sign is an index, and the number inside the radical is a radicand. So in a radical expression, the number under the radical sign is the radicand, and the index gives the degree of the root. For a cube root, the degree is 3. If there is no index, the degree is 2, which means square root. So if I happened to not see any number right here, then it would just be a square root. So let's recall what you know about square roots. Since 5 squared is 5 times 5, which is 25, then the square root of 25 is going to be 5. Notice these guys are opposites of each other. So squaring and square rooting are opposites. Squaring and square rooting are opposites, and I'm going to put a little cloud around that because it's pretty important. So we're just going to do a couple basic examples of what that means. So here we're square rooting 4x squared. In other words, we're asking ourselves, what times itself gets me 4x squared? Well, what times itself gets me 4? 2. And what times itself gets me x squared? X. So this answer is 2x. Here I have the cube root of 125. So I'm asking myself, what multiplied by itself 3 times gets me 125? Well, if I take 5 times 5 times 5, notice this is a group of 3. So that's why I'm using that as my cube root. So the cube root of 125 is 5. What about the 4th root of 16? What multiplied by itself 4 times is 16? Well, it can't be 4 because 4 times 4 is 16, but there's only 2 there, so I know it's not 4. But if I do 2 times 2 times 2 times 2, there's my group of 4, and it's the same number repeated. So the 4th root of 16 is 2. Here I have the cube root of 27. What multiplied by itself 3 times gets me 27? Well, 3 times 3 times 3. And what multiplied by itself 3 times gets me x to the 6th? That's going to be x squared times x squared times x squared. So the answer is 3x squared. Now here, notice how we do not see a number in the index location. That means this is just a square root. So what's the square root of 36? 6. What's the square root of x to the 4th? X squared. So here are my solutions to all of those first ones. Now we have some more vocabulary. So there is a relationship between squaring and square rooting. Since 5 squared is equal to 25 and the square root of 25 is equal to 5, we know a square root gives the original factor of a perfect square before it was squared. So instead of having multiples of the same factor, like 5 squared is 5 times 5, or 5 to the 5th is 5 times 5 times 5 times 5 times 5, a radical does the opposite. It divides the expression into a smaller power. So another way to express that is with rational exponents. And rational exponents are just fraction exponents. So it's where the exponent is a fraction. Let's do some examples. So here we have our rule, and I'm going to kind of make that stand out as well. If we have a number and it's risen to a fraction exponent, then that's going to mean that the power goes with the base inside a radical, and the number on the bottom of the fraction is going to go where the index belongs. So we're going to convert some of this stuff now. In this first example, I have 25 risen to the 1/2. So because I have a fraction exponent, I know I'm going to need a radical, and I'm going to put 25 on the inside. Now, I don't need to draw my 1 because that would just be an invisible 1 exponent, and I don't need to write in my 2 in the index because I don't need to write in a square root symbol with a 2. So I'm going to leave it as square root 25, but that's easy, so I'm just going to call that 5. For letter B, I have 12a to the 3/4. Well, I only need to put something underneath a radical if it has a fraction exponent. 12 does not have a fraction exponent. 12 has an exponent of 1. So I'm going to write 12, and then I'm going to put in my radical. The part that's going under the radical is the a. Now notice the 3 is the top of the fraction, so the 3 is going with the a, that's the power. And then the 4 is going with the root. So it's going to be power over root. And we're done. All we're doing is rewriting. In this next example, I have parentheses around this. So that means everything is getting risen to the 2/3. So I'm going to put in my radical symbol. I'm putting in 64a. Risen to the 2nd because the 2 up top is going with the base, and then the 3 on the bottom is going in the elbow of my radical. Let's keep going. So now I have a to the 7/5. I need my radical, and I'm putting my a in there. The 7 is the top number, so it's going with the base. The 5 is the bottom number, so it's going in the radical. On letter E, this is similar to B. 5 does not have an exponent of 1/4. X has an exponent of 1/4. So 5 has an exponent of 1. So I'm just going to carry the 5 down. And then I need to take care of this x with the fraction exponent. So I'm putting in my radical, and there's an x. I don't need to put my 1 in, but I will just so you guys can see it. And then it's a 4th root, so I'm putting in the 4 in the elbow. Finally, for example F, I have parentheses around 27y, so that means everything in the parentheses is getting risen to 2/3. So I'm going to write my radical, put 27y on the inside, put a square on it because that's the top number, and the top number goes with the power. The bottom number goes with the root. So the 3 is going in there in the elbow. Now we want to do that in reverse. Let's do that in reverse. So for example A, we are still following the same pattern. So remember up here, whatever was on the top of the fraction went with the base, whatever was on the bottom of the fraction went in the elbow. So now let's do that in reverse. Whatever's in the elbow is going on the bottom, whatever's the exponent is going up top. So this is going to be B to the 3/5. Here, don't forget that there's a 1 exponent on that 27. So now this is becoming 27 to the 1/3 d to the 5/3. The 1 was at the top, the 3 is at the bottom. 5 at the top, 3 at the bottom. Whatever is in the part of the root, whatever the index is going at the bottom of your fraction for your exponent. Here, this is going to be s to the 2/3. The 2 is the power on the s, so it goes at the top of the fraction. The 3 is the index, so it's going on the bottom of the fraction. This 12 in this next example is just hanging out up front, and it's allowed to do that. So I'm just going to leave it as 12. Then I have x, and I need to worry about the power in the root for that x. The power on the x is 4, so it's going to go up top, and the index is 3, so it's the denominator for my exponent. Here I have parentheses around everything, so I want to make sure I keep those parentheses, so I'm going to go ahead and write 4y. And when I don't see something in the elbow, it's going to be a 2. So now 5 is the exponent, it's going to be 5 over 2. I just have one more example, and if you're not quite sure mathematically what's happening, we will be calculating with this stuff in the next lesson. Right now, we're just working on converting between the two. So there's an invisible 1 on that 256, and remember, whatever your exponent is on your base, that's at the top of your fraction for your exponent. Whatever your index is the denominator of your exponent. So I'm going to have 256 1/4. So 256 risen to the 1/4, a risen to the 8/4, and that could be reduced to 2. We are now done with this lesson. I hope that everything's making sense. If you have questions, make sure to bring them to me in class, and have a great evening.